All right, so we are up to section 5.4, day 1, Gaussian elimination / row operations on matrices. Wow, sounds loaded. It is. Page 171 is where we're up to. Boy, I tried to avoid a pre-lesson for as long as I could. We were on a good run, but obviously we got some wrinkles we need to iron out. So let's dive right in. This I would refer to as old school. In other words, you should be very comfortable, very familiar. Number one, we've done it in this class. We've done it in Algebra 2, Algebra 1, etc., etc. So your strategies, you've got a lot of them. You've got substitution, elimination, etc., etc. But this one I've even made easy because if you look at this and you say, hey, wait a minute, that's a gift. That's the same thing as 2y equals 8. Divided by 2, I get y is 4. And I put that in right here. I get 2x plus 24 equals 4. Subtract 24 from both sides. I get negative 20. Divided by 2, I get negative 10. So my answer is negative 10, comma 4. All right. Why am I throwing that at you? Well, that's the way you would do it without Gauss. So what is Gauss all about? Well, first of all, one of his main characteristics is he takes the letters off. So look at it. 2, 6, 4, 2, 6, 4. 0, 2, 8, 0, 2, 8. He's like, why do we need the letters? You know it's x, then it's y, then it equals constant. So deal with it that way. Just imagine that they're there. So I just imagine him in some cave, with a rock. He's doing his math on some rocks, and he just doesn't want to keep scraping his knuckles on the rock or something. So this is his little shortcut. So here's the thing. He doesn't just stop here. He says, wouldn't it be nice if we could have this look like this? Now you may be wondering why. You'll see in a minute. So what he's saying is, you want ones on the diagonal. Anything underneath the 1 needs to be a 0. And then you've got some random numbers. So, okay, well, first of all, this right here, upper left-hand 1, is the number 1 goal. Get a 1 in the upper left-hand corner. I can't emphasize that enough. Well, if that's the case, and I look at this one, I could say, hey, I'm going to divide this by 2. Well, that's the way the old school mindset might be. So this is the new school. Dividing this by 2, remember, this is row 1. This is row 2. What they're going to call that is R1, and they're going to call R2, R2. So if my number 1 goal is to get a 1 there, I'm going to take row 1, and I'm going to multiply it by a half. See, I'm introducing you to the language you're going to need to be somewhat familiar with. So if I did that, I could say, okay, I'm going to divide that by 2 or multiply by half. That'd be a 1, that'd be a 3, that'd be a 2. Okay, notice we're one step closer to the Gaussian goal. What's the only thing that doesn't fit in the Gaussian definition? Well, remember, we want 1s here, we want a 0 here, and then some random numbers in that triangle. Well, if I look at this row, I could just do the same thing. Take half of row 2. So half of 0 is 0, half of 2 is 1, half of 8 is 4. And now here's where Gauss says he just likes it this way. This says 0x plus 1y equals 4. In other words, y equals 4. It just spits it out. I can see it from here. Y equals 4. And then I can plug this into this imaginary 1x plus 3y equals 2. So that's 12. So I have x plus 12 equals 2. So I'm going to subtract 12, subtract 12. So I get x is negative 10. You see, same answer, a little different method, but it's good, okay? So let me make sure this is very clear to you guys. I sound like a president. Let me be clear. You would not use Gaussian on a problem like this. I just don't see that happening. But you do need extra strategies for these whoppers. You were taught Kramer. Kramer works awesome. Now you're going to learn Gaussian. Why do I need both? Some students love Kramer. Some students love Gauss. But this may sound very fickle or thin, but you're going to be told on your test, use Gaussian. And we're going to look at your work. Or there's going to be questions about Kramer. And if you don't use Kramer, then obviously you didn't learn it. So we're expecting you to know both of them, okay? More quivers, or more arrows in your quiver, or more quivers. So look at it. This is an X, then a Y, then a Z. So we need to now find 3 variables, just like we did with Kramer's rule. This one has been handmade for Gaussian. This is a dream for Gaussian. You've got your 1s on your diagonal, you've got your 0s underneath it, and then you've got these random numbers above the 1s. Why is this Gaussian's dream? Well, because look at this final row here. This final row just says z equals -2. That's what it says. 0x plus 0y plus 1z equals -2. So z equals -2. It's like, there you go. So now what do? Well, you move back up the ladder because this row, which is row 2, says 0x plus 1y plus 3z equals 1. I'm going to put z as -2 right here, so I get y minus 6 equals 1. Add 6 to both sides, I get 7. Now I know z is -2 and y is 7. I'm going to put it in this top one, which says 1x plus 3y minus 2z equals 4. X plus 3 times y, which would be 21. -2 times z, which would be 4, equals 4. So this is 25, so I'm going to subtract 25 from both sides, so I get x is -21. So my answer would be -21, 7, -2. So even with this problem spoon-fed, perfectly placed in Gaussian language, Gaussian thought, it still takes quite a bit of work. This right here is the meat and potatoes. So bear with me. And here we go. I'm going to get rid of this so we have some space. And the next thing I'm going to do is put our goal up here. 1, number, 0, 1, number, 0, 0, 1, number. Think about it. If you get to here, you simply start on the bottom and you say z equals whatever that is. And you plug that number into here and you find y. Then once you found x and y, you plug it in here and here and you find x. So in a nutshell, that's Gaussian. Okay, let's do it. Remember, this is your number 1 goal. You have to get a 1 in the upper left-hand corner. Why? You'll see. So I see this little -1 right here, and I say, hey, that is gold. So what I'm going to do is I'm going to multiply this by -1, and I'm going to switch it with our 1. So really, I'm going -1, R2, and I'm just switching them. So I'm going to say, all right, and I'm going to take the letters off in one big swooping motion. So this times this is 1. This times this is -2. This times this would be a 1. This times this would be -9. Now I'm just going to put that below it. 3, -7, -2, -20. Then I got 2 and 2 and 1 and 2. Okay. So I said this is your number 1 goal, and now you need to attack down. This is your number 2 goal, and you've got to let go of everything else. So what I'm saying to you is, I'm going to get rid of this so it doesn't confuse us. I want this thing to be a 0. What am I going to do? That's why we have a 1 in the upper left-hand corner. We're going to multiply this by -3 and then add it to this. The fancy way of saying it is 3R1 plus R2. We're going to multiply the first row by -3, then we're going to add it to row 2. But here's an extra thing you have to know. If this comes second, then R2 is what's going to be replaced. It's going to be new. So, what's -3 times 1 plus 3? 0. What's -3 times -2? 6. Plus -7 is -1. What's this times this? -3. Plus -2 is -5. -3 times -9 is 27. Plus a -20 is a +7. All right, little by little, We are getting towards our goals, our Gaussian goals. Our number 3 goal is to have a 0 in this spot. So this time we're going to multiply the top row. See how valuable that 1 is? By -2. And so what we're doing is we're going -2 R1, and then we're going to add it to row 3, replacing R3. That's what that means when this comes second. That'll be important on your homework. So this times this plus this is 0. We're loving it. This times this is 4 plus this is 6. This times this is -2 plus this is -1. This times this is 18 plus 2 is 20. All right. Now we've taken care of that. So in review, upper left-hand corner, getting a 1. Then get that 0. Then get that 0. Our fourth step is to get that middle, well, the thing on the diagonal, our second 1 to be a 1. Well, if you look at this, wouldn't it be easy just to multiply the second row by -1? So that's the fancy pants way of saying it. And now we're just going to do it. Well, that'll just stay. That'll be a 1. That'll be positive. That'll be negative. Why would we do that? Because our fifth step is now to use this 1 to attack down. Now, the fact that this is a 0 means it's not going to change that 0. I'm going to multiply this by whatever I need to, and then add it to this to eliminate it. So that'll be -6. So I'm going -6 R2, and I'm adding it to R3. So this times this is 0 plus 0, 0. That's good. We didn't want to replace that 0. What's this times this? -6 plus this, 0. What's this times this? That's -30. Plus another -1 is -31. What's this times this? 42. What's 42 plus 20? That'd be 62. Now look at it. Now something's jumping out at me. I'm going to go like this. I'm essentially going to divide this row by -31. You see what I'm doing? Fancy pants, I'm going -131 R3. And so this would be 0, 0, 1, and this would turn into -2. And look what happened. I got my zeros here in this triangle, just like here. I've got 1s on my diagonal, and I just got some random, not so random numbers, but it is going to solve it for us, because now we move bottom up. In other words, z equals -2. All right, now we move up. What does this say? Well, essentially it says 1y plus 5z equals -7. Put that -2 right there. We get y minus 10 equals -7. Add 10 to both sides, and we get 3. Now we know y and z. Put at the top, 1x minus 2y plus 1z equals -9. Put things where they belong. Well, that's x. -2 times 3 is -6. Plus z equals -9. This is -8, so I'm going to add 8. And I'm going to get x is -1. So the answer would be -1, 3, -2. Ooh, slide some parentheses in there. Whew! This will give you a little workout. Good luck on your packet lesson.